Alright, how's everybody doing today? We're going to continue on with our solving of equations. We're just going to bump it up a little bit here. Talk about multi-step equations. We've done single step, where you've either added or subtracted, multiply or divide, using the opposite operation to isolate or get our variable to one side by itself. Then we did two-step, where we had to either add or subtract first, then multiply or divide, again using the opposite operations. Now we're going to look at some multi-step equations, and that's our essential question. How do we solve these multi-step equations? Okay, I'm going to go through a couple of examples here, but first we'll look at combining like terms. Okay, when the terms are on the same side of the equal, we want to combine them, just as if we're adding, subtracting, combining like terms. And then once we do that, then we're going to solve it like the two-step equations. If we happen to combine and there's x's on both sides, then we would add or subtract to get them to the same side, and I'll show you that. But we're pretty much solving them like the previous problems. So if you look at this problem here, 5 equals 5x minus 23 plus 2x. Okay, since I have m's here and here, we want to combine that. They're on the same side of the equal here, so it's just 5m plus 2m. That's 7m minus the 23. And now we're doing the exact same thing we just got done doing. Add the 23 to both sides. This gives us 28 equal to 7m. So 28 equal to 7m. Remember, a number and a letter next to each other are multiplication. So the opposite is to divide. 4 equals rm. And we can always plug it back in to check it. 28 minus 23 is 5. So it checks. Okay? Take a look at some other examples. Find the solution here. Find x. Okay? You'll notice we have a little distributive property to do first. So we're going to do that. Negative 8 times a positive 2 is negative 16x. Negative 8 times a negative 1 is plus 8. Now it should look familiar. It's just like what we've been doing. Subtract the 8 from both sides. Opposite operations. Cancels out. Negative 16x equals, what do we got here, 28. Divide out the negative 16. X is equal to, we're going to get a negative. You can simplify this down. 4 goes in there, 7. In here 4, so I would take that. That's also goes into there 1 3/4. That's also negative 1.75. I know you guys like decimals. I would take that. Okay, it's correct. So distributive property, and then it just turns into a two-step equation. Here you'll notice we have x's on both sides, and we've got fractions. There's a way to go about getting rid of the fractions in these problems, and that's by finding the least common denominator. You know, if we were adding or subtracting fractions, we'd want to know what do they both go into. Okay? Take that least common denominator and then multiply each term, all 3 terms in this case, by that number, and you'll cancel. So over here we know that the least common denominator would be 12. For 4 and 3, they both go into 12. So if I multiply each one of these by 12, okay, I could take the 12 that's right here, and I can cancel out here. I'm changing the colors here a little bit. Here's a 12 here. It'll cancel here and here. I get a 1. I get a 3. 3x times 3 is 9x. Times 12 here. 3 goes in itself once, and here 4. I get a minus 4x. And 12 times 10 is 120. Okay? Take that least common denominator. I multiplied each of these by 12 so that I can cancel out my denominator and get a 1. Look, no more fractions. 5x is 120, combining like terms. Undo the multiplication by dividing. X goes into there, what, 24 times? Okay? So there's 3 different examples there. A little refresher here on the distributive property. Again, remember on that first example, you combine like terms because the m's were on the same side of the equal. Okay? We'll look at it next time where they're on different sides, but right now they're on the same side, same as those two, so you just combine them. Okay, don't try to add 4x over. They're on the same side of the equal, so just combine like terms. and then solve it like we've been solving it. Okay, like I mentioned, we just kicked it up a notch here a little bit, add a little twist. Okay, hopefully that's been helpful to you. Get that in your notebook, watch this again so you make sure you understand everything. Bring your questions in tomorrow and we'll go over that, and then we'll do some examples in the class. All right, hope you guys have a good one. See you then, bye.